Oracle in MuleSoft. Now we are focusing on Oracle. Now we are focusing on Oracle. Oracle Corporation, formerly Software Development Laboratories, Relational Software Incorporation, and Oracle System Corporation, global corporation that develops and markets computer software applications for business. The company is best known for its Oracle database software, a relational database management system, and for computer systems and software such as Solaris and Java. Acquired in its purchase of Sun Microsystems in 2010, Oracle is based in Redwood Shores, California. Here you can see the integration architecture of the MuleSoft Oracle EBS connector. The Oracle EBS offers different technologies or products to address various types of integrations. The most widely used integrations for enterprise applications are data-centric integration. The next one is integration through web services using Oracle e-business suite. E-business suite integrated SOA gateway, ISG. Here you can see Oracle EBS 12.2 connector is inside Mule application. This Mule application is Mule application interacts with other external applications here, and Mule application interacts with Oracle here. And web service call is passed from Mule application to Oracle, and Oracle web service response is passed from Oracle to Mule application. Inside the database, PLSQL APIs, integration repository, and integration repository are inside Oracle, and database interacts with PLSQL API and integration repository here. And here you can see the Oracle e-business suite. Here that the Oracle e-business suite 12.2 connector Mule for the endpoint connector for Oracle e-business suite 12.2 EBS 12.2 connector facilitate connection between Mule runtime engine, Mule integration, and Oracle e-business suite 12.2 applications. Here you can see the connector architecture in Oracle EBS 12.1 connector. Oracle EBS offers different technologies or products to address various types of integrations. Most widely used techniques of integration with enterprise applications includes data-centric integration, event-driven integration using Oracle Business Event System, and XML gateway. And integration through web services using Oracle e-business suite integrated SOA gateway, ISG. Here you can see the Oracle business suite. Here the business event, XML gateway inbound, AQQ tables, open interface tables, views, concurrent programs, PLSQL API, business events, XML and e-commerce gateway, and integration repository are in Oracle here. Here business events and XML gateway inbound are connected to AQQ tables. Here you can see these things are in a separate box, and Oracle interacts with Oracle EBS connector, and here the Oracle is connected to Oracle EBS connector via receive messages, and here Oracle EBS connected to Oracle via database connection, and here the Oracle is connected Oracle EBS connected to Oracle via web service call, and Oracle is connected to Oracle EBS connector via web service response. Here XML gateway, inbound queue, consumer, business event topic consumer, and processes are in Oracle EBS Connector, and Oracle EBS Connector interacts with other external applications. Here you can see attributes and architecture in Oracle PeopleSoft Connector Mule 4. The component interface has the following 4 main attributes. Component interface name. Each component interface requires here the component interface. Component interface name. Each component interface requires a unique name. The programs calling a component use the name of the component interface to access the properties and methods. Keys. Get keys, create keys, find keys. Keys are special properties containing values that receive an instance get keys, so list the instance find keys of the component interface. You can add, remove, and change keys in PeopleSoft application designer. Keys are created automatically when you create the component interface. Get keys, the map to fields marked as search keys in the component search record. Create keys generated in CI when use tab on the component properties dialog allows the add action. Find keys map to fields marked as both alternate search keys and search key in the component search record. Properties and collections, field and records. Properties provide access to both component data and component interface settings. A property can correspond to a field or a scroll. Collection. Component interface collection is special type of property that correspond to the scroll containing fields and subordinate scrolls as defined in its underlying components. Type of properties. Standard properties are assigned automatically when a component interface is created. User-defined properties map to the record field on the PeopleSoft component that and are displayed in the PeopleSoft application designer. Methods. A method is a function that performs a specific task on a component interface at runtime. There are 2 main types of methods, standard and user-defined. Standard methods are those available all the component interfaces, and the following are the standard methods that a connector supports: create, cancel, find, get, save. User-defined methods are created in the PeopleSoft application designer to provide that functionality to component interface. Here you can see component search keys, component people code functions, and fields and scrolls are in the component. Here the keys keys are connected. Here the keys, methods, and properties and collections are inside component interface, and keys are connected to component search keys. Method are connected to people's code functions, and properties and collections are connected to field and scrolls, etc. Here the PeopleSoft application, you can see a people code, and here the COM, VB, and COC++ in the external application here. Those are connected to component interface via API. Here you can see how to use a decision matrix in matrix to design integration patterns in Oracle ERP Cloud. The Oracle ERP Cloud is complete modern cloud ERP suite when advanced capabilities include analytics to react to market shift in real time and automatic updates to stay up to date in real time. It has following applications to solve a specific ERP needs within an application, an enterprise. One, Oracle Cloud Financials delivers decisive insights into a company's financial position and profitability with comprehensive global solution. Oracle Cloud Retail Solutions provide complete set of mission critical capabilities and cloud services and hardware. Oracle Enterprise Performance Management EPM enables modeling and planning across finance, HR, supply chain, and sales. Here you can see Oracle ERP Cloud Interact and other client and mobile and API databases and etc. And other things interacts with the Mule. Here you can see an example of Oracle ERP Cloud integration pattern decision matrix. Decision integration patterns present a conceptual, repeatable solution to common technological problems. Following architecture principles are recommended to build decision metrics during the architecture design process to support sustainable enterprise data integration architecture. One, the use study standard connectors to avoid custom development whenever possible. Always use MuleSoft out-of-box connectors where possible. Wherever possible, and avoid to use the custom code when connecting with various sources and target applications. Connectors always shield the business services from the technology and API changes from the third-party product. Event-driven architecture interacts with the event-driven interactions enable asynchronous communication and reduce the pollution overhead on source systems when there is a need to broadcast messages to multiple downstream apps. Follow API-led architecture. API-led connectivity provides the approach for connecting the exposing assets with this approach rather than connecting things point to point. Every asset becomes then a managed API. This image shows how to find the right decision pattern based on your needs. As an example, if you need to outbound data from cloud financials, and you have a large volume of data with complex data view transformations involved, you could choose BICC pattern as per matrix below. Here the bulk data and financial outputs, outbound and bulk data with complex transformations. Here you can see the process overview. Identify the cloud application. For example, financials and retail is connected to define connectivity type. For example, inbound and outbound. Then it's connected to find the volume and SLA details, and it's connected to identify decision criteria, and it's connected to make choice, and it connected to implement the solution. Here the decision analysis, decision to be made. I want to find right Oracle ERP cloud integration pattern based on my use case requirements. Here the financial outbound, financial inbound, financial outbound, retail app inbound, and retail apps outbound. Here the bulk data with complex transformations, bulk data and real time. Here the bulk data with complex transformation. If it is financial inbound, EBDI with parking lot database. If it is financial outbound, BICC, retail apps included. Then SFTP with parking lot database, and retail apps outbound, BDI. Here the bulk data. Then for financial inbound, FBDI, and financial outbound, BIP, and retail apps inbound, SFTP, and retail apps outbound, RIB. Real time Oracle Web Service, financial inbound Oracle Web Services, financial outbound on business events, retail apps inbound Oracle Web Services, and retail apps outbound, RIB. Here you can see business event design patterns in Oracle CFIN. Now that you are able to find which integration patterns to use based on the decision matrix previously mentioned, I will show I will show you how to implement the patterns with MuleSoft API-led architecture. Business events via Oracle Cloud Financials, CFIN outbound. Here ERP business events publish data that can be consumed by MuleSoft application and further processed to downstream applications. You can also enable pub sub patterns with AnyPoint MQ or similar message platform where there are multiple subscribers interested in the same data steps. Event is generated from the Oracle CFIN or Oracle Product Data Hub PDH. Review the list of business events supporting real-time integration was from PDH. MuleSoft received the event. publish the event to any messaging system for interested subscribers to consume the process. Here you can see Oracle Cloud Financials CFN IN is connected to CFN events X API via business events. Here the CFN event API, event X EXP API and MQ in MQE in experience here. So this is Oracle Financial Cloud inbound business events here, and MQE is connected to MQQ1 and MQQ2 here. MQQ1 and MQQ2 and customer master PRC API, MDM customer PRC API are in process. Here MQQ1 is connected to customer master PRC API, and Q2 is connected to MDM customer PRC API. Here the CDM rules SYS API, finance DW SYS API and finance MDM SYS API are in system. Here the customer master PRC API is connected to CDM rules SYS API and is connected to rules engine, and the customer master PRC API is connected to here finance DW SYS API and is connected to DW, and here the MDM customer PRC API is connected to finance MDM SYS API and is connected to MDM. Here you can see an example of FBDI integration pattern. File-based data import pattern with staging databases via Oracle. Via Oracle Cloud Financial CFIN inbound. This pattern recommends storing the data in an intermediate stage before processing it from the staging database to Oracle ERP cloud. This allows you to perform any complex transformations and validation rules against data. Additionally, you can take advantage of throttling the data from the source to the target in better way due to staging database. FBDI is one of the ways to integrate with Oracle ERP cloud. This pattern mainly used for loading bulk data into cloud ERP. File-based data import process involves generating FBDI file, uploading file to ERP, and then receiving callback from ERP service. This pattern can be used in any Oracle ERP cloud app, not just Oracle Finance Cloud. Steps: process the input data message based on the order they come in. Each message will be parked in a storage for a few minutes parking time, so the system has chance to throttle the number of messages processed concurrently. A maximum number of the parallel process can be configured to throttle the outgoing calls. Generating file in FBDI format based on the data received from the source application. It get triggered through the detection of trigger file or according to the integration schedule. Reading source file based on the trigger file name or integration schedule, transforming the source to FBDI, and staging FBDI file optional. Load the file generated from above in the Oracle ERP cloud. Once data is loaded, the Oracle ERP cloud asynchronously call back the Mule API with the result of the load and import process. Here you can see Oracle Finance Cloud inbound FBDI pattern with staging DB here. Here the enterprise scheduler is connected to Oracle FBDI PRC API, which is in the process, and here the Oracle FBDI PRC API is connected to staging DB Syst API via control the message flow, generate message in FBDI format, achieve archive the FBDI file, and it's meant manifest the send and achieve the ERP cloud. Here the FTP files EXP API is connected to SFTP, and here the staging DB Sys API is connected to staging database, and here the Oracle enterprise schedule is connected to Oracle FDB PRC API, and it's connected to Oracle FBDI Sys API, and it's connected to Oracle Financial Cloud FCIN, and here the FCIN is connected to Oracle callback EXP API, and it's connected to Finance FTP Sys API, and it's connected to SFTP, and here the SFTP files EXP API and Oracle fallback EXP API in experience layer, and staging DB Sys and Oracle FBDI Sys API and Finance FTP SFTP Sys API in system. Here the example of Oracle ERP cloud services. This pattern recommends SOAP RESTful cloud services by leveraging Oracle standard web services available for CRUD create, read, update, delete operations. This pattern is applicable for both inbound and outbound steps. Step source application send the data to the Mule experience API endpoint. Oracle ERP Cloud exposes the web services to publish data, and these are available as business object. Payload received from the source is mapped to the format expected by the cloud business services. Operational steps. Data can be logged in a parking lot DB to maintain readability, traceability, and transaction history. And MuleSoft makes calls to underlying web services to publish data into Oracle ERP Cloud, and then the request is processed by the Oracle ERP Cloud, and the response is sent back. Response is returned to the sent back, and here the response is returned to the source application, source system. Optional step: as part of post-processing, the transaction log is updated in a parking lot database. And user is notified about the completion of the request with status. Here you can see web invoices EXP API, for example, in experience layer is connected to source web app, and also connected to Oracle ERP PRC API in process, and it's connected to Oracle ERP Sys API in system, and it's connected to Oracle ERP Cloud apps via REST or SOAP. Here you can see Oracle eBusiness Suite, and here the open interface tables, views, concurrent programs, PLSQL API, business event, XML, and e-commerce gateway, and integration repository. These interacts with the Mule Oracle EBS connector, and it's with external applications. Here you can see use case XML in Oracle eBusiness Suite 12.2 connector Mule 4. As an example too, we can consider add connector in Studio here in Oracle eBusiness Suite 12.2 connector Mule 4, and you can also add the connector using Exchange. Here we are considering add the connector in Studio. Step 1 in Studio create a Mule project. Step 2 in the Mule palette view click X search in Exchange, and step 3 in Mule add modules to project, type EBS in the search field. Step 4 click the connector's name in available modules. Step 5 click add. Step 6 click finished. As an example 3, we can consider parameter connection. Connection types for this configuration here. Type PLSQL. This is in Oracle eBusiness Suite 12.2 connector Mule 4. Now we are considering, before you begin in Oracle EBS 12.1 connector, to use this information, you should familiar with Oracle EBS Mule runtime engine, Mule endpoint connectors, endpoint studio, Mule concepts elements in the Mule flow, and global elements. You need login credentials to test your connection to your target resource. To use this connector with Maven, view the pom.xml dependency information in the dependency templates in Anypoint Exchange. Here you can see the POM file information in Oracle EBS 12.1 connector. Replace the x.x.x with the version that correspond to the connector you are using. Obtain the most up-to-date pom.xml file information. Access the connector Anypoint Exchange and click dependency snippets. Now we are considering add libraries for this connector to in web service endpoints in Oracle EBS 12.1 connector. To subscribe business events or to the XML gateway queue, the JMS configuration requires 2 external libraries. Go to the connector, the JMS configuration. Click setup under the message setup drivers. Upload the selected upload and select your libraries. Oracle AQ API can be retrieved from the EBS instance at the $home/RBDMS/JLib/AQ Oracle JDBC driver can also be found in the instance at Oracle_home/JDBC/lib/JBDC6.jar. Now we are considering add the connector to a studio project in Oracle EBS 12.1 connector. Add the connector using Exchange here. In Studio, create a Mule project. Click the Exchange icon in the upper left of the Studio taskbar. In the Exchange icon, click login and supply your Anypoint platform username and password. In the Exchange, search for EBS. Select connector and click add to project, and then follow the prompts to install the connector. Now we are considering log PSQL and web service request in responses. In Oracle EBS 12.1 connector, to log the PSQL and web service requests and responses when using connector, configure a logger. For PSQL request and response, to add this line to the loggers element in the log4j2.xml. For the web service requests and responses, add this line to the loggers element in log4j2.xml configuration for Mule app. Following example shows the loggers element. With the async logger, the configured to log the web service request and responses. Here you can now we are considering use case call and login operation in Oracle EBS 12.1 connector. The sample flows calls an operation every 30 seconds and logs its output. Drag your scheduler and then set the frequency to 30 seconds. Select Oracle EBS, then get party site from the Mule palette view, and then drag it to the flow. Then configure its input and drag the logger and set its message to payload. In the use case XML, here is the code for aforementioned example here. Now we are considering JMS in connector configurations in Oracle EBS 12.1 connector reference. This parameter name, parameter here, the name, type string, and this name, the name for this configuration, connectors reference the configuration with this name. Now we are considering, before you begin in Oracle PeopleSoft connector Mule4. To use this information, you should be familiar with the PeopleSoft Mule runtime engine, Mule, enter anypoint connectors, anypoint studio, and Mule concept elements in the Mule flow and global element. You need login credentials to test your connection to your target resource. Now we are considering POM file information in Oracle PeopleSoft connector Mule4. Replace x.x.x with version that correspond to the connector you are using. To obtain most up-to-date pom.xml file information, access the connector with anypoint exchange and click dependency snippets. Now we are considering what's new in this connector in Oracle PeopleSoft connector. The recognized user interface in connectors configuration. The input and output operations is JSON. Fixed date conversion is save operation. Now we are considering add the connector using exchange in add the connector to studio project in Oracle PeopleSoft connector Mule4. In the studio, create the MuleSoft project and click the exchange icon X in the upper left corner in the studio taskbar. In the exchange, click login and supply the endpoint platform username and password. Then in exchange, search the PeopleSoft, then select the connector and add to the project and follow the prompts to install the connector. Now we are considering log request and responses in Oracle PeopleSoft connector Mule4. To log request and responses using responses when logging the connector, configure a logger by adding this line to the loggers element in the log4j2.xml configuration file for MuleLab. Following example shows the loggers element with the async logger line added. You can view the app log as follows. If you are running the app from the anypoint platform, output is visible in the anypoint studio console window. If you are running the app using the Mule from the command line, the app log is visible in your OS console. Unless the log file path is customized in the app log file, log4j2.xml, you can view the app log in this default location mule_home/logs/appname.log. For information about the app, see the configuring logging in the documentation. Now we are considering use case retrieving a collection of employee records in Oracle PeopleSoft connector Mule4. Create a new Mule project in the anypoint studio. Drag the HTTP listener to the canvas and configure the following parameters: display name, extension configuration path. Drag the PeopleSoft invoke operation next to the HTTP endpoint component and configure it according to the steps below. Add the new PeopleSoft configuration by clicking the plus sign in the basic settings field. Configure the global element, completing required fields with your credentials. Add the PSGOA library. Add the CI personal data to the component interface IDs. click the test connection to confirm the Mule can connect the PeopleSoft instance, and then if the configuration is successful, click OK to save configuration. Otherwise, reviewer correct the incorrect parameters and then test again. Back to the parameters properties editor. If of invoke operation, configure the remaining parameters: display name, extension configuration, component name, operation, the connector settings, then the add the transform message co-element between HTTP endpoint and the PeopleSoft endpoint to provide the input parameters required by the find method, and the fields should be automatically populated. Inside, add the transform message after PeopleSoft element to display the response in the browser. Add the logger scope after the JSON transformer to print the data is being passed to the PeopleSoft connector in the MuleSoft console. Save and run the Mule application, then open a web browser and check the response after entering URL http://localhost: 8081 find $ID equals 0004 and ampersand name equal ampersand last name and etc. And if there are records in your MuleSoft database whose keyprop underscore EMPL ID contains the value mule, you should get a JSON collection with these records. Otherwise, you receive the empty collection. In this example, input parameters of find operations are optional. Now we are considering default configuration in Oracle PeopleSoft connector reference Mule4. Here the field name, the name for this configuration, connectors reference to the reference the configuration with this name. Now we are considering, before you begin in Oracle Siebel connector 4.0, to use this information you should familiar with Oracle Siebel Mule runtime engine, Mule anypoint connectors, anypoint studio, Mule concepts, elements in the Mule flow, and global elements. You need to log in credentials to test your connection to your target resource. To use this connector Maven and we view the pom.xml dependency information in the dependency snippets in the anypoint exchange. Because of how closely the connection is coupled with Siebel CRM, you should have a working knowledge of Siebel business component, business object, business services, and integration object. Siebel connector requires the following two Siebel jar files: siebel.jar and siebel ji_xxx. Choose the Siebel ji_xxx.jar based on the local of the Siebel installation. For instance, the local Siebel installation in US_en, use the Siebel ji_enu.jar and Siebel.jar and Siebel ji_enu.jar are available in the Siebel home for /8.1.1.11 tools_1 /classes folder in the Siebel server. Siebel home is the installation directory of Siebel. The connector is now conglomerate with the previous three modules: Oracle Siebel business project objects, Oracle integration objects, and Oracle Siebel business services. Now here you can see the POM file information in Oracle Siebel connector 4.0 Mule4. Replace the XYZ with the version that correspond to the connector you are using. To obtain the most up-to-date pom.xml file information, access the connector in anypoint exchange and click the dependency snippets. Here you can see the connector in Design Center in Oracle Siebel connector 4.0 Mule4. In Design Center, click setup, then upload, browse for select the driver for this connector on your file system and upload it. Alternative search for and select the driver is already uploaded. Click the trigger. You can create global element by selecting this connector as the trigger. If the global element is not needed, you can use the HTTP listener or schedule trigger. To create the optional global element for connector, set these fields here. Name, enter the name for the configuration to reference it later, or user. Enter the Siebel username to be used. Password, enter the password corresponding Siebel password. Server, enter the server IP address of your Siebel instance. Port, enter the port number, default value 2321. Server name. enter the Siebel Enterprise Server name and RSA encryption. Choose if you want to use RSA encryption. Default value is false. Object manager. Enter the value of the object manager of your Siebel instance. Language. Enter the corresponding to the local Siebel instance. Default value is ENU. Encoding. You enter echo encoding type supported by Siebel server. The default value is UTF-8. Select the plus sign to add the component. Select the connector as a component and configure these fields. Select the connector configuration that previously connected and fill the fields of the operation that you are using accordingly. Now we are considering add the connector using the in the exchange. Add the connector into a studio project in Oracle Siebel Connector 4.0. In the studio, create a Mule project. Click the exchange icon next in the upper left of the studio taskbar. In exchange, click login. Supply your endpoint platform username. In exchange, search for Siebel. Select the connector and click add to project. Follow the prompt to install the connector. Here you can see logged requests and responses. In Oracle Siebel Connector 4.0 Mule 4 to log requests and responses when you are using a connector. Configure the logger by adding the line to the loggers element in the log4j2.xml configuration file for the Mule app. Following example shows loggers element with the async logger line added. You can view the app log as follows. If you are running the app log app from the endpoint platform, output is visible in the endpoint studio console window. If you are running the app using the Mule from the command line, the app log is visible in your OS console. Unless the log file path is customized in the app's log file log4j2xml, you can also view the app log in the default location mule_home/log/appname.log. For more information about the app log, see the configuration logging in the documentation. Here you can see a use case in Studio. The use case in Studio. Example use cases in Studio in Oracle Siebel Connector 4.0 Mule 4. The following common use cases for the Siebel version 4.0.0 connector. Create a business component, action, account, etc. Create a new Mule project in Endpoint Studio. Add a suitable Mule inbound endpoint, such as HTTP listener. To begin the flow, drag create business component operation from the Siebel JDB palette into the canvas and select that select it to open the properties editor. Configure the operations parameters. Drag the transform message connector between HTTP listener and the Siebel connector on the flow. Configure the input payload with the desired fields. To the execute the business service, create contract, create account. Add the new Mule project in the Endpoint Studio. Add a suitable Mule inbound endpoint such as HTTP listener to begin the flow, and drag the execute a business operation from the Siebel JDB palette into the canvas and select it to open the properties editor. Configure the operations parameters. Drag the transform message connector to the HTTP listener and the Siebel connector in the flow. Configure the input payload with the desired field. Execute Siebel adapter. Create a new Mule project in creating an integration object. Create a new flow create a new Mule project in the Independent Studio, add a suitable Mule inbound endpoint such as HTTP listener to begin the flow. Drag the create business component operation component from the Cbel JDB palette into the canvas, and then select it to open the property editor, configure the operations parameters. Drag the transform message connector between HTTP listener and the Cbel connector in the flow. Configure the input payload with the desired field. Here you can see use case XML in Oracle Cbel connector 4.0 Mule4 in Mule4. HTML extract from the project been using the Cbel connector here. Now we are considering Cbel in configurations in Oracle Cbel Connector 4.0 reference Mule4. The parameter the name for the configuration, connectors reference the configuration with this name. Now we are considering create a secure Oracle connection in configure an Oracle TLS database connection in Oracle Connector. The following example shows how to configure a secure Oracle connection in Endpoint Studio. In Studio, navigate to the global element view, click create to open the choose global type view. In the filter field, type database, select database config and click OK. In the database config window, the connection field, select Oracle connection. To configure, click the configure to add the Oracle JDBC driver and select either use local file, install the library using local file, and add the Maven dependency, install the Maven dependency to add the project. 6. Set host to localhost, port to 1522, user to system, password to Oracle, and the instance / service name to exe. Click TLS. In the true store configuration section, set the following field: path, some path / client truststore.jks, password, some password, and type jks. In the keys store configuration section, set the following field: path, some path / client store.jks, password, some password, key password, some password. Due to Java Secure Socket extension JSSC, you must set the password and key password field with the same password value for the key store configuration. Type jks. 10. Click the test connection to confirm that the Mule can connect to the database. Click OK. The following screenshot shows the secure Oracle connection general and TLS configuration window in Studio. Here you can see trust store configuration section in the and the fields here, and here you can see here the path, password, key password, path, password, and type. And here you can see key store configuration section. Here the path, password, password, key password, type. In the configuration XML editor, TLS colon context configuration look like this here. As an exception example, we can consider this occurred in Oracle EBS connector. Here you can see the links href equal https etc, and this is d2rlvs 3d 9006 ap.cloudfront.net /s3 _ images / 1242474 / ebs _connector _ 0.1 png and etc. and you can see here java.lang reflect.undeclared throwable exception at com.sound.proxy and etc. And here at org.mule.modules.oracle.connection manage multi-strategy.test connectivity etc. And yeah.